Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next video. In this video, we are going to solve some more problems on integration, particularly indefinite integral. Okay, dear students, in indefinite integrals, upper limit and lower limit is not given. Okay. While solving indefinite integrals, we add a constant. Okay. While in solving definite integrals, we do not add this constant c sign of constant. Okay, dear students, actually this set of problems is very lengthy, having been chosen from the same book which we are following in our videos on calculus, that is to say calculus early transcendentals by James Stewart, Slim Watson and Daniel Clegg. This group of problems is very lengthy. It consists of problems from problem number 9 to problem number 54. Okay, about 45 problems. Okay, quite obviously, in one video, limited problems can be solved only. Okay, so dear students, in this video we are going to solve problem number 9 to problem number 18. Okay, that is to say 10 problems. Statement for these problems is combined, that is, evaluate the indefinite integral. Then remaining statement is different for every problem. Okay, so it is here not necessary to state every problem at this initial stage. Okay, when we will solve a problem, then we will state its statement also. Okay, so now, as usual, before going to solve our problems in a formal manner, we first visit several snapshots which will be helpful in understanding the concept involved in solving these problems. Okay, so first snapshot is about the integral of f from a to b. Okay, this is the form. Okay, sign of integration from a to b, where a is lower limit of integration and b is upper limit of integration, and in between sign is integral sign. Integration from a to b, fx dx. Here fx is the function, the function fx is the integrand. Okay, this fx is called integrand. Okay, the function fx is the integrand. Integral from a to b fx dx. Here x is the variable of integration. Okay, x is the variable of integration. When you find the value of the integral, you have evaluated the integral. Okay, when you find the value of the integral, you have evaluated the integral. Okay, we are also going to evaluate 10 problems in this video. Okay, dear students, the next snapshot or copy paste version is about formulas used. Dear students, these formulas are more than required for these 8 problems. Anyhow, our all 8 problems will be covered from formulas given in this table. Okay, we do not need to describe it in any detail. Okay, we have also dealt with this table in our previous video. Okay, next, this is just another version of the same formulas. Okay, almost same formulas, rather it is a little larger collection. There are 20 formulas. Okay, in previous slide perhaps less than 20 formulas were included. Okay, so for example, dear students, formula number 1 will be used in these 8 problems. Formula number 2 will also be used. Perhaps formula number 3 will also be used. Similarly, 5 and 6 or either of these two will also be used. Okay, anyhow, whether it is not very important which of the formula is being utilized in our video. All formulas are equally important for us, because we may deal with these formulas in other problems also. Okay, now we start our solutions in a formal manner. Okay, problem number 9. Sine of integral x into square root 1 minus x square into dx. Dear students, in our previous video we have solved 8 problems in which substitution was suggested by the statement. Okay, the only difference between those 8 problems and these 10 problems is that here we have to choose substitution by our own choice. Okay, in statement it is not given that u is equal to this. Okay, so in this problem we will choose 1 minus x square as u. Okay, u equal to 1 minus x square. When u is equal to 1 minus x square, then du by dx will be equal to minus 2x. Okay, according to power rule of differentiation, and from here x dx will be equal to minus 1 by 2, because dear students, in statement x dx appears. Okay, so in place of x dx we will use minus 1 by 2 du, minus 1 by 2 du in place of x dx, and in place of 1 minus x square under root we will use u under root. Okay, so given integral x into square root 1 minus x square dx becomes equal to sine of integration into u square root into minus 1 by 2 du in the next step, because minus 1 by 2 is constant, so it will be written prior to sine of integration and our next step will become minus 1 by 2 sine of integration u square root or u under root into du. In the next step we have only changed u square root or u under root by power u raised to 1 by 2. Okay, because square root or under root is always equal to power 1 by 2, and here we can also write 2 over square root sign, but it is not necessary. Okay, it is understood that 2 is written. To the extent of 2 it is not necessary to write 2, but in case of 3 or 4 or 5 it is necessary. Okay, so minus 1 by 2 sine of integration u raised to power 1 by 2 into du this. Then next step becomes, according to power rule of integration, next step becomes minus 1 by 2 u raised to power 1 by 2 plus 1, and this increased exponential power will also appear in the denominator. Okay, and simultaneously constant c will be added because we have integrated the given problem. The only difference is that here still u exists, and in the next steps we will eliminate this u and resubstitute the value of u. Okay, so in the next step, minus 1 by 2 u raised to power 3 by 2, because half plus 1 is equal to 1.5, that is 3 by 2. Similarly, this 3 by 2 will also appear in the denominator, and we know that fraction in the denominator is reversed. That is to say, denominator of the denominator appears in the numerator. So next step will become minus 1 by 3 u raised to power 3 by 2 plus c. This is our answer. The only step remaining is that we have to resubstitute u by its original value. So its answer, our required answer will become minus 1 by 3 1 minus x square raised to power 3 by 2 plus c. Problem number 10, 5 minus 3x raised to power 10 dx. Let u equal to 5 minus 3x. Okay, as it is not limited by the statement, we ourselves keep this as u. So then u is equal to this. Then this implies that du by dx will be equal to minus 3. And this implies that from here dx will be equal to minus 1 by 3 du, because in the statement dx simply exists. Okay, so in place of dx we will write minus 1 by 3 du, and in place of 5 minus 3x raised to power 10 we will write u raised to power 10. Okay, so integral 5 minus 3x raised to power 10 dx becomes equal to integral u raised to power 10 into minus 1 by 3 du. Okay, what is this? This is in place of dx. From here, because minus 1 by 3 is constant, so it will be taken out and it will be written prior to sign of integration. That is to say, in next step we have minus 1 by 3 into integral u raised to power 10 into du. Now, dear students, in the next step we are going to integrate it as per rules of integration. That is to say, power rule of integration. That is to say, exponent or power will be increased by one number, and then that increased power or exponent will also appear in the denominator. So our next step will become minus 1 by 3 u raised to power 11 divided by 11 plus c. Dear students, in the denominator 11 will be multiplied with the 3 and we will get 33. So next step will become minus 1 by 33 u raised to power 11 plus c. To this extent our answer is complete. The only step remaining is that we have to resubstitute u by its original value. So our answer will become minus 1 over 33 5 minus 3x raised to power 11 plus c. Problem number 11, integral t raised to power 3 e raised to power minus t raised to power 4 dt. Let u equal to minus t raised to power 4. Okay, we will make this substitution. Okay, so this implies that when u is equal to minus t raised to power 4, then du by dt will be equal to minus 4t raised to power 3. What is this? This is power rule of differentiation. That is to say, power or exponent reduced by one number, that is to say, power or exponent appears as a multiplying factor, and then power or exponent is reduced by one number. Okay. First, exponent of power appears as multiplying factor, and then in the second step, power or exponent is reduced by one number. From here, we will get t raised to power 3 t cube into dt equal to minus 1 by 4 du, because in the statement t raised to power 3 is given and dt is given. So in place of these two multiplying factors, we will substitute this by minus 1 by 4 du. So given statement, integral t cube e raised to power minus t raised to power 4 dt becomes equal to integral e raised to power u into minus 1 by 4 du. Yes, students, here because minus 1 by 4 is constant, so it will be taken out and it will be written prior to sign of integration. So our next step becomes minus 1 by 4 integral e raised to power u into du. Now in the next step, we are going to integrate it as per rules of integration. We know that integration of exponential function is always exactly same as it is, no change. Okay, so after integration we will get minus 1 by 4 e raised to power u. This is the answer of this integration, but at the same time we will add c as a constant of integration. Okay, to this extent our answer is complete. However, the only step remaining is that in the last we have to resubstitute u by its original value, and hence our answer becomes minus 1 by 4 e raised to power minus t raised to power 4 plus c. Problem number 12. Sin t 1 plus cos t square root into dt, let u equal to 1 plus cos t. Okay, 1 plus cos t. Okay, we are going to make this substitution. So this implies that du by dt will be equal to minus sin t. Okay, we know that differentiation of sin t is cos t, while differentiation of cos t is minus sin t. But integration of cos t is plus sin t. But here we are not going to integrate. We are going to differentiate cos t. Okay. So formula of differentiation will apply. Okay. From here, this implies that sin t dt will be equal to minus du, because sin t and dt both appear in the statement. So in place of sin t dt, we will replace these two multiplying factors by minus du. Okay, so given statement sin t into square root or under root 1 plus cos t dt becomes equal to u square root or u under root, because 1 plus cos t is equal to u, but in the statement 1 plus cos t is in the square root mod, and we know that square root is power 1 by 2. So integral u square root or under root into minus du. Here minus 1 is a constant, so we take it out and it will be written prior to sign of integration, and we get minus integral u raised to power 1 by 2 du. In the next step we are going to integrate it as per rules of integration, that is to say power rule of integration. Here power or exponent will be increased by one number, and then that increased power or exponent will also appear in the denominator. So our next step will become equal to minus u raised to power 1 by 2 plus 1, and at the same time this quantity, that is 1 by 2 plus 1, will also appear in the denominator, plus c, because whenever we will apply integration formula we will add c. Okay, So in the next step we will get minus u raised to power 3 by 2, because half plus 1 is equal to 1.5 or 3 by 2, and this 3 by 2 will also appear in the denominator plus c, and we know that fraction in the denominator is reversed, that is denominator of the denominator appears in the numerator. So our next step will become minus 2 by 3 u raised to power 3 by 2 plus c. To this extent our answer is complete. However, the only step which is yet to be done, yet to be taken, is that we have to resubstitute u by its original value, and hence our answer becomes minus 2 by 3 1 plus cos t raised to power 3 by 2 plus c. 13. So, integral sine pi t by 3 dt. Let u equal to pi t by 3. Okay, we are going to make this substitution. This implies that when u is equal to pi t by 3, then du by dt will be equal to pi by 3, because we are differentiating it with respect to t. So in place of t we will get 1 or unity. So its derivative will be equal to pi by 3. Okay, while t will be converted into 1. This implies that dt will be equal to 3 by pi du, because dt is appearing in the problem statement. Okay, so in place of this dt we will replace it by 3 by pi du, and we will replace sine pi t by 3 as sine u. Okay, so the given statement integral sine pi t by 3 dt becomes equal to sine of integration sine u 3 by pi du. Okay, in place of dt we have used its alternate value in terms of u, that is 3 by pi du. Here, dear students, 3 by pi are both constants, so this constant factor will be taken out and it will be written prior to sign of integration, and our next step will be 3 by pi sign of integration sine u du. In the next step we are going to integrate this factor as per rules of integration, and we know that integration of sine u is minus cos u. Okay, differentiation of sine u is plus cos u, but integration of sine u is minus cos u. Okay, so our next step will become 3 by pi minus cos u plus c. To this extent our answer is complete. The only step which is yet to be taken is that we have to resubstitute u by its original value, and hence our answer will become minus 3 by pi cos pi t by 3 plus c. 14. Sine of integration secant square 2 theta d theta, let u equal to 2 theta. Okay, we are going to make this substitution. When u is equal to 2 theta, then du by d theta will be equal to 2, because we are differentiating it with respect to theta. So in place of theta we will get 1 or unity, and hence our derivative will become simply 2. This implies that d theta will be equal to 1 by 2 du. So the given statement sine of integration secant square 2 theta d theta becomes equal to secant square u, because in place of 2 theta we have used u, and in place of d theta we have used 1 by 2 du. Here 1 by 2 is a constant, so it will be taken out and written prior to sine of integration. So our next step will become 1 by 2 equal to 1 by 2 integration secant square u du. And then in the next step we are going to integrate this factor as per rules of integration, and according to the formula of integration, integration of secant square theta is tan theta, but here in place of theta we are using u, so its integration will be 1 by 2 tan u plus c, because at the time we integrate we simultaneously add a constant of integration, that is c. To this extent our answer is complete. The only step left is resubstitution of u by its original value. So our answer will be 1 by 2 tan 2 theta plus c. 15 dx over 4, sine of integration dx over 4x plus 7, let u equal to 4x plus 7. Okay, we have we are going to substitute denominator by u. Okay, so when u is equal to this, then du by dx will be equal to 4, because we are going to differentiate with respect to x. So in place of x we will get 1 or unity, and derivative of u with respect to x will be simply 4, and from here dx will be equal to du by 4. So given statement, that is dx over 4x plus 7 becomes equal to sine of integration 1 by u into du by 4. Here 1 by 4 is constant, so it will be taken out and written prior to sine of integration, and our next step will be 1 by 4 integral du by du. In the next step we are going to integrate this factor according to rules of integration, and we know that formula for this type of integration is log u. Log of absolute value of u, or log of modulus value of u, or mod of u. Okay, so our next step will be 1 by 4 natural log ln. Ln stands for log natural log absolute value of u plus constant of integration c. To this extent our answer is complete. The only step remaining is to resubstitute u by its original value, and hence our answer will become 1 by 4 log 4x plus 7 plus c. 16 integral y square 4 minus y raised to power 3 power 2 by 3 du. Let u equal to 4 minus y cube. Okay, we are making this, going to make this substitution, that is 4 minus y cube is equal to u. When u is equal to this, then du by dy will be equal to minus 3y square. What is this? This is power rule of differentiation. That is to say, power or exponent appears as a multiplying factor, and in the next step power or exponent is reduced by one number. Okay, so du by dy is equal to minus 3y square. This implies that from here y square into dy will be equal to minus du by 3, because in the statement y square and dy are existing, so we will replace these two multiplying factors by minus du by 3. So our given statement, that is integral y square 4 minus y cube raised to power 2 by 3 dy becomes equal to integral u raised to power 2 by 3 minus du by 3. Here minus 1 by 3 is a constant, so it will be taken out and written prior to sign of integration. So our next step becomes minus 1 by 3 sine of integral u raised to power 2 by 3 into du. In the next step we are going to integrate it in accordance with the rules of integration, and here power rule of integration will be applied, and we know that in this rule power or exponent is increased by one number, and then that increased power or exponent also appears in the denominator. So our next step will be minus 1 by 3 u raised to power 2 by 3 plus 1, and at the same time this value, that is 2 by 3 plus 1, will also appear in the denominator plus c. This will be equal to minus 1 by 3 u raised to power 5 by 3 divided by 5 by 3. Okay, because 2 by 3 plus 1 will be equal to 5 by 3 plus c. Okay, in the next step, yes, so we know that fraction in the denominator is reversed, denominator of the denominator appears in the numerator. So our next step will be minus 3 by 15 u raised to power 5 by 3 plus c. Okay, definitely minus 3 and 15 these will be cancelled, and minus 1 by 5 will become, okay, 3 into 5 equal to 15. So our answer will to this extent our answer is complete. Minus 3 by 15 u raised to power 5 by 3 plus c. The only step remaining is to resubstitute u by its original value and also to simplify minus 3 by 15. So our answer becomes minus 1 by 5. 4 minus y cube raised to power 5 by 3 plus c. 17. Sine of integral cos theta over 1 plus sine theta d theta, let u equal to 1 plus sine theta. Okay, we are going to substitute denominator by u. Okay, so this implies that when u is equal to 1 plus sine theta, then du by d theta will be equal to cos theta, because we know that in differentiation of sine theta is cos theta, and from here cos theta into d theta will be equal to du, because in the given statement cos theta and d theta appears in the numerator. So in place of these two multiplying factors we will replace it as by du. So given statement, that is integral cos theta over 1 plus sine theta d theta becomes equal to integral du by u. Now in the next step we are going to integrate it as per rules of integration, and we know that here formula of log absolute value will be used. Okay, so its answer will be natural log ln log natural absolute value of u or modulus value of u or mod of u plus c. Okay, this is as per formula of integration. Okay, this is equal to log 1 plus sine theta u plus c. What we have done, we have resubstituted u by its original value. To this extent our answer is complete. Dear students, here we can use simply parenthesis in place of modulus value or absolute value. The reason behind this is that 1 plus sine theta can never be negative. Okay, because we know that values of sine theta varies in between 1 and trigonometric values varies between 1 and minus 1. For example, sine 90 is equal to 1 and perhaps sine 180 is 0, etc. Anyhow, trigonometric values vary from 1 to minus 1. Okay, so even if at the most, suppose we say that a value of sine theta is minus 1, even then it becomes 0, not minus 1. Okay, it can never be negative. So we can replace this absolute value or modulus value or mod by simple parenthesis. Problem number 8. Integral z square over z cube plus 1 dz, let u equal to z cube plus 1. That is to say, we are substituting denominator by u. So this implies that when u is equal to this, then du by dz will be equal to 3z square. What is this? This is power rule of differentiation. That is to say, power appears as multiplying factor and power or exponent is reduced by one number. That is why its derivative is 3z square. From here, z square into dz becomes equal to du by 3, because in the statement z square and dz are appearing in the numerator. So in place of z square dz, we will use its alternate value in terms of u as du by 3. So integral z square over z cube plus 1 into dz becomes equal to integral 1 over u dot du by 3. Here 1 by 3 is constant, so it will be taken out and written prior to sign of integral. So we will get next step as 1 by 3 into integral du by u, and in the next step we are going to solve this. We are going to integrate it as per rules of integration, and we know that here formula which will be used is that 1 over u du is equal to natural log of absolute value of u or modulus value of u or mod of u. So our next step will be 1 by 3 log absolute value of u plus c. To this extent our answer is complete. The only step remaining is that in place of u we will substitute its original value, and hence our answer will become 1 by 3 log absolute value of z cube plus 1 plus c. Okay, this is the end of our video. Till next video, Allah Hafiz.